we're still simplifying rational expressions in this next lesson, but now we are adding or subtracting the fractions. And remember, when we're adding or subtracting fractions in order to get an idea of what that new fraction answer looks like, we need to have a common denominator. So I'm going to look at each denominator and the factors that it contains and pick the least common denominator. So I don't need to factor the denominators in the first problem because they already have factors. So in the first denominator, there's a factor of 5, a factor of a, and a factor of b cubed. So I'm going to have a factor of 5, at least one factor of a, and at least b to the third in my common denominator. Now when I look at the second denominator, it has a factor of 3. That's not a factor I've already included in my LCD, so I'm going to make sure that I include that. It has a squared. I already have included one factor of a, but this means I would have to include another one as well. And then it has b cubed. That's already more than enough factors to get the b squared. So my LCD is going to be 15a squared b cubed. So I need to decide what to multiply each fraction by in order to create this denominator. So I'm going to set this up to get that ready to go. So all I've done right now is rewritten the problem. And then remember, when you're creating this common denominator, you're changing the denominator of the fraction, but in order to not change the fraction completely, those same changes must be made by multiplication or division to the numerator as well. So to make 5ab cubed into this common denominator of 15a squared b cubed, this needs to be multiplied by 3a. So I'm going to do the same thing in the numerator. And to make 3a squared b squared into 15a squared b cubed, I need to multiply by 5b. And I'm going to do that here as well. So I'm going to have 6ax over 15a squared b cubed plus 20by over 15a squared b cubed. So this has one denominator now because it's common, so I can write the entire expression over one denominator. And 6ax and 20by are not like terms. Okay. I do need to notice that the numerator, I can factor out a 2, and that would leave 3ax plus 10by. But this big factor doesn't exist in the denominator, and there's not even a factor of 2 in the denominator to cancel that out. So I can either leave it in the factored form or not, but there's nothing that can cancel further to simplify that answer. All right, so I'm going to look at the next problem the same way. So the first thing I'm going to do is I'm going to go ahead and factor those denominators so I can see what they look like in factored form. And again, if you're unable to factor these, you need to be coming into tutorial. So now when I look at this and I decide on the least common denominator, from this first fraction right here, my denominator must have, because remember, we're not canceling anything out of the denominator. We're looking at what needs to be multiplied new into each denominator so that they can all have the same factors. So x plus 3 times x plus 2 already exists in the first denominator. In the second denominator, I have x plus 2. One of those is accounted for, but I have another x plus 2 as well. So that's what I'm looking for as my least common denominator. Okay? Which means from this first fraction, I'm missing a factor of x plus 2. So I would multiply that into the numerator and the denominator. And in my second fraction, I'm missing a factor of x plus 3. So I would multiply that into the numerator and the denominator. I'm going to keep, so we see we have a common denominator. So I have x plus 3 times x plus 2 times x plus 2 in each of the fractions. But in the numerator, I have some arithmetic to do. I have this multiplication problem plus this other multiplication problem to do. Okay? So I have x times x plus 2 being added with 2 times x plus 3. So following normal order of operations, I can't combine any like terms till I've multiplied this out and see what I have. So I have x squared plus 2x plus 2x plus 6. And that's all still over that same denominator. And then in the numerator, I can combine like terms. So right here gives me this. So I have x squared plus 4x plus 6. Again, still all over the common denominator. And so I would notice here, I would try to factor this numerator. But there are no values. So the factors of 6 are 6 and 1 and 3 and 2. And neither of those are going to add to make 4x. So this numerator is not factorable, which therefore means no factors will be able to cancel with the factors in the denominator. So then this is it. All right, looking at part C, we have a subtraction problem. Okay, again, the first thing I want to do is I want to view each denominator in its factored form so I can really see which factors my common denominator is going to have to contain. So notice they both have a factor of x minus 3. Okay, so again, creating my least common denominator. In my first fraction, I have a 2 and an x minus 3. When I come to my second denominator, the x minus 3 is already accounted for. The 4 is partially accounted for with the factor of 2, but I need another factor of 2. So my least common denominator is going to be 4 times x minus 3, which means the denominator in that first fraction, or in the second fraction, doesn't need to change, and in this first fraction, I just need to multiply it by 2. So I'm going to have 2 times x minus 5 over 4 times x minus 3. Minus x minus 7 over 4 times x minus 3. And again, I have a common denominator, so the denominator is 4 times x minus 3, but there's work to do in the numerator. I have 2 times x minus 5 minus the entire quantity of x minus 7. So this is like having 2x minus 10 minus x plus 7 over 4 times x minus 3. And then I'm going to go ahead and combine like terms. So I'm going to have x minus 3 over 4 times x minus 3. The x minus 3's in their entirety can cancel out, and I'll be left with 1/4. So like we talked about before, this can also be done with a complex fraction. And don't freak out about the complex fraction. Look at what you are doing. So here we have x is being added with x over 3. And then that's being divided by a different subtraction problem. Okay, so first your job is to make each of these, order of operations would say do parentheses first. So within these parentheses, we need to do these problems. So think about this as having a 1 in the denominator. The least common denominator in the first addition problem is 3, which means this first fraction needs to be multiplied by 3. So I'm going to have 3x over 3 plus x over 3, or that will simplify to be 3x plus x over 3. So I have that part still being divided by whatever I get here. And again, here I would multiply top and bottom, or numerator and denominator, by 6. So I'd have 6x over 6 minus x over 6. So this is 6x minus x over 6. And now I'm going to go through the division process like I normally would. So this is 3x plus x over 3 times the reciprocal. And then to see if anything can cancel, I'm going to factor. So in this first numerator, I'm going to take out, I could totally combine like terms. So let's call this 4x. Sorry about that. It would be much easier to do that sooner. So this is 4x. And 6x minus x is 5x. All right, so let's look at what we have. We have 4x. I'm just going to rewrite it so we can see it more clearly. Over 3 times 6 over 5x. So the factors of x can cancel out. 3 and 6 both have a factor of 3, leaving a factor of 2 here. And so we are going to have 8 over 5 as our final answer to that simplified expression. So the try this looks a little more complicated, so I wanted to walk through it with you guys. But again, just follow the same steps. So we have 1 over x plus 2 being added with 1 over x minus 5. That's going to create one fraction that's being divided by 2x squared minus x minus 3 over x squared minus 3x minus 10. So I have an addition problem to do here. There's two different factors in my denominator. My LCD here, from the first fraction, I need a factor of x plus 2, but from the second fraction, I need a factor of x minus 5. So I need both those factors in my denominator, which means this first fraction needs to be multiplied by a factor of x minus 5. And if I do that in the denominator, I want to also do it in the numerator. And this second fraction needs to be multiplied by a factor of x plus 2, again in numerator and denominator. So then I have x minus 5 over x plus 2 times x minus 5 plus x plus 2 over x plus 2 times x minus 5. And so this is going to be one fraction. The denominator is x plus 2 times x minus 5. In the numerator, I have to combine like terms. And so I'm going to get 2x minus 3. Okay, so I finally turned that first set of parentheses into one number. Now that's still being divided by this entire second polynomial. Okay, so where were we? We have this, and it's being divided by this expression. And remember, I have to know how to factor the numerator and the denominator. So it's going to be like 2x and x, and 3 and 1, minus and plus. So this first one is 2x minus 3 over x plus 1, and the second one here is x minus 5 times x plus 2. And again, if you can't factor those, you should have been in tutoring since Unit 2. That's when we did this factoring, and you need to come in. So we have this being multiplied by the reciprocal of this. So I'm going to make sure I write this as the reciprocal. Sorry about the bell. And now I'm going to look at if factors from the numerator can cancel with factors from the denominator. So x minus 5, x plus 2, and 2x minus 3 can all be canceled. So I have a 1 in the numerator, and I have x plus 1 in the denominator. So that would be the simplified version of this fraction.